Konrad Zuse was a science nerd and inventor of the future. But in 1935, he was just another engineer in Berlin, trying to progress and get along with his colleagues. But he had a sharp mind, and he was easily bored.
As a student, my father studied at the same university where I'm working. The name was at this time Technische Hochschule Charlottenburg. And there he started machine construction. Then it was boring for him. Then he changed to architecture. It was boring for him.
At the Heinkel Aircraft Company, he did endless maths equations to calculate the effect of wind on airplane wings. But the adding machines of the time were not easy to use. Everything had to be inputted by hand. The monotony was sending Zuse crazy, and he was driving his colleagues up the wall too.
These calculations were horrible for him. And he thought about, at this time, he thought about, how can I make it easier?
Zuse thought he must not be alone in his hatred of the adding machine. He was sure there was a huge amount of people that would appreciate a machine that could do complex calculations without having to input every tiny detail by hand.
He saw a market in Germany at this time, and he thought, everyone needs such a machine, and then I can get rich.
Zuse's idea became an obsession. He left his job and moved in with his parents to work on it.
Came to his parents and said, I need a living room. I want to build up a big machine which makes mathematical calculations.
They had no idea that their son's eccentric tinkering would change the future of the entire planet. Zuse began work on a machine that would do more than just complex calculations. It would be able to be programmed to actually think for itself. A computer. But to program it, he needed a language that both man and computer could understand. Zuse found that the solution lay in an ancient mathematical system called binary. He learned how it used sequences of ones and zeros to represent numbers similar to Morse code. It was a language so simple, even a machine could follow it. The next challenge was how to physically represent these ones and zeros in a machine. Zuse thought he could do it with thousands of mechanical switches. A sequence of switches turned on or off would represent any number. He started to build the switches by hand.
He took metal sheets, and then he took a saw and he made a template and structures. He had about 30,000 metal sheets.
One by one, Zuse turned the sheets into the thousands of intricate metal switches that would create his binary sequences. However, if even one switch was out of alignment, none of them would work. He had to find a better way. But world events threatened to derail his entire project. In 1939, Konrad Zuse was called up to fight for Hitler. But instead of heading for the front lines, Zuse managed to work in aerodynamics with the German Air Force. He tried to convince them about his computer concept, but they didn't see a use for it. So Zuse persevered on his own, after work at night. Then he came up with a brilliant solution to replace the cumbersome mechanical switches. He salvaged electrical relays from old telephones and used them instead. The relays became the switches that would create his binary sequences. It was the major turning point for Zeus's conception. No more awkward moving parts, just the efficient hum of electricity. December 1941. The computer was finished. 6 years of work and 2,500 electrical relays were waiting to be switched on. It was the moment of truth. Zeuser fed a complicated mathematical problem into the computer. Within minutes, it delivered the correct answer. He had done it. Konrad Zeuser had built the world's first fully programmable electronic computer.
He had a vision. He constructed a completely new type of calculating machines or computers. Partially, he was really a genius.
But because of the raging war, the world's attention was elsewhere.
There was no press, there was no sensation, there was no report in any newspaper.
After the war, Zeuser started one of the world's first computer companies. And Konrad Zeuser's binary-based design is the universal standard for every computer in the world.